Hey everyone, this is Daniel for Rock the JVM, and in this video, we're going to do something different. Instead of the regular programming tutorial that I usually come up with on the channel, today I have a guest, and I have none other than Martin Odersky, the creator of the Scala language. And we talk about all things Scala, about learning and teaching Scala, about the Scala improvement process and the future of Scala, and so much more. This is a wide-ranging conversation. And this is a first for me. So if you like this video, let me know, and I might make more of it. And I can talk to other influential people in the programming space about a wide range of topics that are important and relevant to us as software engineers. So let me know if you like it, and I'm going to take this feedback into account. In the meantime, let me introduce Martin Odersky. Martin is a computer scientist, researcher, and professor of programming methods at EPFL in Switzerland, and the creator of the Scala language. Since 2002, he has been working on Scala as a direct and practical implementation of much of his research on code analysis, static type systems, and programming language theory. Scala is now used at major companies in the world, including Apple, Disney, Adobe, Databricks, X, also known as Twitter, and many others. He also founded TypeSafe, a company focused on commercial support for Scala and major frameworks based on Scala, which then turned into Lightbend and then Akka Incorporated. Before his work on Scala, Martin was instrumental to the implementation of Java generics and to the Java-C reference compiler, which pretty much every Java developer uses. So please enjoy this wide-ranging conversation with none other than Martin Odersky. Professor Odersky, Martin, thank you so much for making the time for this conversation. I was super excited, and I've been waiting for this for a long time. I wanted to start with teaching kids to code. I'm teaching kids to code in Scratch, which is a programming tool based on these little blocks that look like Lego pieces. And many Scratch programmers that, say, overgrow the Scratch language, they ask me for a programming language to teach them real programming. And Scala is obviously my favorite language, but most of the answers that I usually get get suggestions for is something like Python or JavaScript or things like that. Have you ever thought about teaching Scala to kids or to very beginning programmers? How do you think about this?
I'd like to be able to do it, definitely. And I think Scala would be quite suitable for that. The issue is that it requires a lot of specialized examples and time and frameworks, and somehow this just didn't materialize. So I don't have the time to develop that myself. I'm probably not very good at it because I imagine to teach programming, you probably want to use some sort of video games or things like that as an example, as the next step beyond Scratch or something like that. And that requires a lot of preparation, and I'm probably not the best person to do it. But I find it very intriguing, and it would be cool if we could do it, definitely.
I just imagine if you did have the time. Obviously, you're teaching more advanced programmers. You're teaching in university. You're teaching programming methods and coordinating PhD students and research and stuff. So obviously, you're doing far more advanced stuff than just teaching the very basic elements of programming. But if you had all the time in the world, let's say you had completely free reign over a curriculum or things that you would teach to kids, what would you focus on, and how would you approach teaching Scala in particular to kids?
Oh, uh, I guess the importance is always to come up with good examples. So I'd probably teach them in a sort of mixed functional approach. But I guess a popular first example is something like what they did in Logo, like a snake or something like that,
Mm-hmm.
that goes through a labyrinth or things like that. And that's obviously there's mutation, but you would limit the mutation to essentially things that they see moving on the screen, and the rest, I guess, you would make functional without making a big deal about it. I
Yeah.
mean, I wouldn't even use the word, I guess. Just use it naturally, I guess. And otherwise, just start with a simple thing, probably. Yeah. I mean, just top level statements, things like that. Introduce like the classes and methods. Well, still top level statements, then methods, then classes. So that's probably a natural progression.
Yeah, I
But I
mean,
guess
in in
these
in
things.
in my experience, sorry to
Mm,
disrupt the flow
yeah,
of thought. In my experience, I saw kids um, very receptive to these visual things, like
mhm,
snake games or even programming stories. Like Snow White walks 3 steps and then asks the
yeah,
fairy whatever, and then the fairy gives Snow White the apple, and Snow White says something, and then a little message displays on screen. So these step by step things, and they seem to be quite attracted to this sort of thing. I was wondering how you would think about something like that, because obviously there are a lot of kids that would like to learn programming. They're attracted to technology. They spend an increasing amount of time on with screens and laptops and tablets and phones and things like that. And also parents, they're very interested in imparting this sort of skill to kids. So I was very curious how you would approach that. Obviously, Scala is my favorite language, and I would be very, very happy to teach that thing to kids.
mhm.
I was thinking about ideas of how to do that. So this was essentially a very self-interested question. Uh, yeah, in terms of the beginner programmers that you saw, not necessarily kids, but also adults, have you seen anything in particular that people struggle with when learning Scala? Obviously, you have a lot of experience teaching university students and stuff. I was wondering what kind of struggles students have when learning to code in Scala, and how you think of approaching that.
Mm. So the one thing which comes completely natural to us, but which I've seen students struggle with, is recursion.
Hmm.
They seem to have problems with that. A lot of them in the first weeks or so, to
Hmm.
just wrap your minds from this mindset where you think in loops, to think in terms of recursion and decomposition. So that's hard. I noted that I used to give, when in the early days of TypeSafe, we had like a 2-day course, and the course was, the first day we did like the basics, and which was like language elements, pattern matching, recursion, these sort of things, and the second day we did like more library stuff like collections and things like that. And I noted that I did a lot better the second day than the first day. And I think the answer is, well, yes, because if you think in terms of recursion or loops or pattern matching, you think you need to put many steps together for the final results. Whereas with collection operations, a bulk operation, I just essentially fuse a map with a fold or something like that. And that's much simpler because there are fewer steps to sort of conceptualize in your mind. So that was interesting.
And
Uh,
have you
and
seen
yes,
anything? Go ahead, please.
yeah, I think recursion is really essential but hard for newcomers, in particular, probably newcomers who started with imperative languages, and that's basically everyone.
Have you seen people learn Scala as their first language? Obviously, as a not necessarily as a kid, so as
Mm.
a say a would-be programmer, and learning Scala as their first language. Have you found this to be the case as well with recursion, in the sense that recursion is hard to conceptualize?
I don't know because I haven't really seen that play out in that people actually started with Scala. Well, they tell me about it, but I wasn't able to observe closely to
I
see
see.
by what steps did they do this and things. Yeah, so
Yeah,
I'm
the
not
reason
sure.
I'm asking is because I heard and I know a couple of stories from my own experience with Rock the JVM as well. When people learn Scala as their first language, obviously there are very few, but they learn as they learn Scala as their first language, or a functional language as their first language, the kind of stuff that we consider hard as imperative programmers, they're not as hard for them, because there's nothing for them to unlearn or wrap their heads around and bypass their current way of thinking. They directly think in mathematical terms, or rather conceptualize recursion as, oh, a function calls itself. For sure. I mean, yeah.
Yeah,
And
yeah, yeah.
I
But
was
it's only,
wondering if you have seen this sort of phenomena, or if you know some stories.
I don't know any, but I can well imagine this is the case. But I think the point is, even if you start out that way, let's say you start out with with Python, an imperative language,
Hmm.
then we know there's a progression from like simple statements, left, go right, go up to a loop. So that takes some getting used to the loop.
Hmm.
So basically, we go simple statements, then if, then else, and then loops, and in functional, it's sort of the same thing. So calling simple functions is easy, but the step to recursion, which is the analog of a loop, takes some extra getting used to. And probably it helps if you don't know loops, and probably it's true that those people have less problems with recursion. But I mean, even in mathematics, recursion is a subtle concept, so it's not at all trivial. So
Yes, yes, that's
I'm
definitely the
talking like
case.
with
Yeah.
my academic hat on here. Yeah.
Yeah, because I remember when I was learning programming, I'm one of the classical programmers. I've learned C and then C++ and that sort of stuff. And when I stumbled upon the for loop, like the for structure in C, that's completely non-trivial. There is a lot of there are a lot of things going on in a for loop in C. There are these components that you have to remember. And I remember struggling with that structure and remembering which piece meant what and stuff. I imagine that if I'd learned recursion first, I would probably spend pretty much that same amount of time. But obviously, that's a hypothesis.
Yeah.
Um,
Yeah.
yeah, uh, it's it would be a very interesting experiment to see Scala being taught as a first language. Do you know people using Scala in university to teach beginning programmers?
Yeah. There exist courses like that. Even though I guess for nowadays, if the kids start learning programming at university, more than half of them have already prior experience. But
Interesting.
yeah,
Yeah.
there's for instance the courses by Björn Regnell. He's at Lund University in Sweden, and he changed the curriculum from, I think it was Java before, and now they have the first year Scala and the second year Java. And he actually did some statistics and measurements and had very good experiences with that. So the bottom line was at the end of year two, the programmers who underwent that curriculum, Scala first, Java second, were better Java programmers than people who had 2 years of Java. So you
Oh,
see,
that's
even
fascinating.
yeah, yeah,
That's
that was very interesting to read. Also, I think there's another course at Trinity College and Loyola. There are a number, maybe around 10 universities who teach Scala first year
that's amazing. And
that we know.
it's
There might be
fascinating
more.
that if you measure the performance of the Java programmers after 2 years of Java versus 1 year of Scala and 1 year of Java, there's definitely proof that Scala makes you a better programmer, which is something that we've known anecdotally, really, but
Right. Yeah. Yeah.
it's
Yeah. Yeah. It's good to have the data to back that up. Yeah.
I I wish I had aggregated more data from Rock the JVM, but all I know is stories, but they really corroborate with this sort of conclusion.
Mhm.
Yeah. How about your own students at EPFL? How are they finding Scala?
Yeah, I think it's going well. We teach it in second year, so
Hmm.
for historical reasons, we actually do start with Java in first year and
Okay.
then the Scala in second year and a course on software construction. Um it's a challenging course. The course has changed a bit over the years, so now it's a heavy course, 8 credits, and they learn not just programming, functional programming, Scala programming, but also software engineering. So it's sort of all in one course. But generally, yeah, I mean, we have very good evaluations. Students seem to like it. And yeah, we always get like the occasional student who comes up in the break and says, well, yeah, but Scala, isn't Scala way too slow? Shouldn't we program everything in C or something like that? I mean, there are lots of misconceptions,
Yeah.
but
But
of course, it's also good to have.
it's fascinating that your course is so complex. I was under the impression that you were teaching Scala in a sort of uh, programming paradigm style, like functional programming, and teach the foundations of.
Yeah, yeah.
How are you incorporating the principles of like software, full blown software engineering into the course?
The essentially teaching the scientific method, which so it's an I believe it's an interesting approach. It's my collaborator Clément Pitt-Claudel who designed this part of the course. So essentially, you teach them debugging as an application of the scientific method, not using a debugger. These sort of things, but basically, what is debugging? So I observe a behavior. I have to find out what I would expect. I have to essentially be very meticulous in writing down when the wrong behavior happens. And essentially, then I make hypotheses, I make experiments, and I keep track of everything like I would be in a lab. And where I can't be sloppy and just mix chemical substances and hope for the best. I mean, you're very systematic, you're very, yeah, systematic and precise in doing that. And the same thing goes for debugging and essentially also all sorts of software engineering.
That's fascinating.
Yeah.
That sounds like a course that I wish I'd had in university. If I if I was a student again, I would apply for that course.
Yeah, yeah, it's fun. Yeah,
This
yeah.
is this is great. I was wondering how your students are involved in the evolution of Scala itself. I know you have PhD students and collaborators. How are they involved in the evolution of Scala?
Well, we have so right now the team is a mixture of master students who are who essentially spend part of their time in the lab, PhD students, and two postdocs. And the the students, starting with the master students, they actually do a lot in the practical work. Also, they start writing papers, but they also do a lot of, for instance, one does the CI. The other student is currently figuring out how to uh, get around some deep sitting problems in overloading resolution, these sort of things. They love that. So they go into that and says, okay, so we have a problem with overloading resolution. I have an idea how to make it much better. That was already quite some while ago. Unfortunately, Scala test breaks because Scala test uses some very funky pattern of overloading resolution, and with Scala test, basically the two-thirds of the ecosystem break because they're all using Scala tests. So you can't do that. So the big question is how can we get to sane overloading resolution and have Scala tests not break? And that's what he's currently working on. So
That
it's sort of interesting and details to see, well, yeah, we identify a problem. Maybe many people are not aware of the problem, but it's a problem nevertheless. How can we fix that? So in the case of overloading resolution, it was kind of weird that we uh, what was it? Essentially, we use the so methods have multiple parameter lists, and we use the first parameter list for overloading resolution. So to pick a winner, we only look at the first parameter list. But sometimes that's ambiguous, and then what you think you would do is you would say, well, let's pick those that are sort of in a tie in the first round, and that's among them. Let's use the second parameter list for a tiebreaker, right?
yeah.
But in fact, that's not what happens in Scala. Right now, what happens is you just basically throw away the first match. You say everybody's equal now. So
Start
maybe we
from
find a
scratch.
winner only looking at the second parameter list, even though they lost the first one. And that's kind of this sort of reasoning is kind of non-monotonic and is kind of weird. And we don't want that. But it turns out that, as always, that once you have a certain weirdness, then there's already software out that exploits it. And in our case, it was Scala test, which is, of course, a bit problematic. Yeah. So stuff like that.
This is very interesting, and I wanted to stay here a little bit longer because I think that very few people understand and appreciate the kind of process that goes into the Scala evolution. It's very easy to criticize. It's very easy to consider, I don't know, hey, the compiler is slow or that sort of stuff. But uh, you can't really say that until you appreciate the kind of work that the compiler is doing, so that you can have the strength of the type system. So I have several questions here. I mean, this can branch out in many ways. One that comes to mind is how is you said something about Scala test breaking your intended change in the Scala compiler. I was wondering how the process works in general. If you want to add a feature in the language, or if you want to make a change, if you want to fix a bug,
Hmm.
what's the general process? How does this work from inception to the Scala 3.6.5 or whatever the version is?
Okay, so first there would be typically an issue that's opened, and then somebody will get assigned to it, or somebody volunteers to do it. And then one looks at the issue, one has a hypothesis how one might possibly want to fix this. So you go in the compiler, you do the fix, then you see what tests break. So we have maybe about around 10,000 tests or something like that. So you see whether tests break. But if all tests succeed, then you check in the CI. We also have about 30, no, about more like 40 projects in the community build, which is like most of the big ones, like Scala Test is one of these,
Hmm.
Zio, Cats Effect, these sort of the usual suspects. So they must all be green, or maybe some of them, if some of them are red, then you have to go into their code and analyze, well, is that actually something that should be a bug? Because sometimes we have like things, soundness problems or tightening of the
Hmm.
rules, where we say, well, some code out there uses a thing which is actually known to be unsound. So in that case, we have to make a proposal that they should fix the code, and we have to sort of see in our version, in our copy of the code, to see whether we can fix it for them, and then upstream a PR for their thing. So
So
we
in
do
many
that.
ways, yeah. Go ahead, please.
And if all that is green, then every week or so, this Virtus Lab has the open community build, which is about 1,500 projects, which essentially runs with the current version of Scala, and which flags regressions. And if there are regressions, then they get flagged as separate issues. We have to look at them. We have to decide whether these regressions are serious or not, and whether we have to maybe roll back our changes, which often happens as well, or whether we say, well, these regressions are actually also problems in the code of these projects, which is fixable. There are workarounds, so we can maybe ask them to fix it. So that's sort of a typical process of a bug which is not completely trivial. Of course, most of them, but some of them are fine. It's a clear bug. We fix it. Everything stays green. We move on. So not everything
Yeah.
is as complicated.
Yeah, and we're talking about the Scala compiler here. It has dozens of phases. I think it has. How many phases does the Scala compiler have?
Well, it has close to 100,
A hundred. Okay.
but these are well. I have to qualify that. These are not really phases. They are called mini phases.
Yeah.
So they're batched into phases, and those macro phases that run the mini phases, those that are run standard for every program, are about 10, maybe a bit less than 10, something like that. Yeah.
Yeah, what I wanted to say is that the Scala compiler is not really your day-to-day piece of software. It's a complicated thing, and I often consider compilers and uh, operating systems as pretty much close to the most complex software
Yeah.
that there is, because there are so many things that can go wrong, and everybody relies on you, and you have to have a massive amount of accountability and responsibility to be able to get into that sort of thing. I certainly would think many, many, many times before I would commit something to something like this into the Scala compiler. So I just wanted to say that I appreciate the kind of work that you and your team are doing into the Scala compiler. What do you think is the bottleneck for you right now in terms of the evolution of the Scala language or the Scala compiler?
Um, I think the bottleneck is s- contributors who are experienced enough that we can essentially rely on them to work without hand-holding. We have them, we're fortunate to have them, but
Hmm.
we could always use more of them. And you become somebody who has that level of seniority only by being first a junior contributor and then essentially progressing. But it's sort of the bottleneck is really people at the end of that progression that have to mentor the others. That's a very limited resource.
Yeah. I imagine that's it's a big burden on their time and on their schedule, because not only do they work on some of the most complex software there is, but they also need to mentor other people and help
Yeah,
them or guide them. I don't know, something breaks on their ends, the CI breaks, or a project, a community project to build fails, or something like
yeah,
that.
yeah.
So
We
I
are,
met.
but overall, I think we are in reasonably good shape now. So it's I think the compiler itself is relatively stable. We haven't heard many complaints about compilation speed. Maybe computers are getting faster. The compiler also got faster.
Yeah.
I guess it's also that a lot of the competition got slower, or maybe people are waking up to that not every compiler is as fast as Go or Java C, which are compilers that can be very, very fast because, well, first, there's a lot of engineering in them, but also what they compile is a lot less dense than what Scala compiles. So if you say a typical Scala program is maybe a tenth of a Java program, just to pick a number, maybe it's 2 or 5 instead, then you would expect that at least given the information density, the compiler would be 10 times slower and people wouldn't complain, yet they do complain because it just feels to them that,
Yeah.
yeah.
I, it's definitely the case. I mean, how do you convince people that I don't know, Scala 3 is the language to go, or that they should migrate, or that they should rely on Scala 3 for their business or for their project?
Well, we had we have a constant series of talks which sort of say where Scala 3 is better than Scala 2. So there are clear advantages to changing. It's an altogether better language and quite a quantum leap, I would say. So it's not at all the same as Scala 2. But then, well, it's up to well, we were fortunate that I think the ecosystem of the core libraries they migrated in reasonable time. So some were faster than others, but by now basically they're all on Scala 3. So that's really good. That means that it's really a extremely long, tiny tail of projects, which, well, no, let me qualify that. I think the big problem is Spark, but even Spark is so that you can use it from Scala 3 because Scala 3 and 2.13 are interoperable, and Spark is, I think, basically now on
It's
2.13.
on
So
213, yes. Yeah.
yeah, that's right. Yeah. So even Spark is basically solved now, even though it would be nice if they were on Scala 3, but well, that's isn't in our power
Yeah.
to influence that. Yeah.
It's gonna come at some point, I imagine. I was wondering what you would say to people about the. So you mentioned that the Scala 3 is a league ahead of Scala 2. It's a quantum leap ahead. Um, in what way is Scala 3? And I'm asking for the audience here that would like to understand the details. In what way do you think that Scala 3 is a giant leap ahead of Scala 2? Some people would consider Scala, and the reason I'm asking is because I see some comments in my own private community at Rock the JVM saying that Scala 3 is just Scala 2 with a few keywords changed, like using given instead of implicit, using like a few bits and pieces tweaked here and there, but they are not necessarily getting the idea that Scala 3 is a completely different language with a completely replaced foundation. So I was wondering what you would say to this sort of comment.
Yeah, so I mean, you don't see the foundation. So it is built on a different foundation, or well, on a let's say Scala 2. The foundations haven't been really developed very much. With Scala 3, we had them that influenced the language design. But then on that level, I mean, it's not a completely different language. It's still Scala, right? So it's 2 to 3, but it's still the language family. It's still recognizably Scala. The main difference is a lot less foot guns. So a lot of the things that people got bitten in Scala 2, where they say, for instance, stay away from implicits. Implicits are super dangerous and things like that. I mean, they're very powerful. They can still be dangerous, but I think we removed a lot of the things that bit you, and where people developed cumbersome workarounds and things like that. And we're still doing this. So we're just now shipping the reversed priority of implicits, which solved a lot of problems. So we see that in existing code, that everybody had sort of super complicated hierarchies of manual priority of implicits, that where essentially the implicits in your libraries were added in many different versions, and that's no longer necessary. Or another example is the way we do import suggestions, and the way we reorganize the scoping of implicits. In Scala 2, people were bitten a lot by just missing a crucial implicit import, right? You say, why does my program not run? Well, you should do this incantation, import cats dot syntax dot underscore, something like that. And if you didn't do this, you were completely on your own, just nothing would work anymore. And these sort of things, they are behind us in Scala 3. So in Scala 3, it's clear. It's first the way we organize the implicit systems. You should with newly designed libraries, you should rely a lot less on this sort of wildcard imports that import the world for you. I don't think that with a well-designed systems, that's not necessary anymore. And second, even if you still need to do that, the tooling gives you hints and doesn't block you. So it's part tooling and it's part language. Language came first, but I think with tooling we also made important advances.
This is going to be very interesting and valuable, and I'm saying this because I was bitten in the past myself by the lack of knowledge of which kind of magical import I should add to my code, and nothing would work. I would see red everywhere, and I would frantically search Google or Stack Overflow, or here in these days you would ask Claude or an LLM, hey, which import am I missing? But this is going to be very interesting if you don't have to rely on these magical imports, because it's really a bottleneck. If you're experienced and you know the library inside and out, if you don't know HTTP4S or Cat's Effect or whatever, if you know them by heart, then yes, you have all the imports. You write them by reflex. You don't have to think about them. But somebody who doesn't know that, which is basically 99% of the people, including myself. Okay. they get bitten by the lack of the presence of implicits. How would a system like this work? I mean, you said something like that. If you design your library well, you shouldn't rely on implicits. Without getting into too many details, because we're speaking right now and it's hard to look at code. How would that look like?
No, on implicit imports.
On implicit imports, yes, not on implicits themselves. Sure, I mean, implicits are useful.
They're mostly there. For instance, all these syntax imports are mostly there to support operators. And it's essentially the way we put extension methods with givens together that avoids that. So you can now basically write these methods where they make sense and you automatically get them. You don't need a special import to essentially support some operator syntax for these implicit libraries. So that's the main advantage, that you don't need that anymore.
This is
It's
pretty cool.
essentially how givens and the extension methods play together.
Okay.
Because
That's nice.
yeah. Extension methods is another thing where I really think that there was a breakthrough because I mean, other languages have extension methods, like Kotlin has them and Dart has them, I think, yeah. But the way that we can actually essentially have abstract extension methods in a base class, like for an implicit, where we say we have, I don't know, an ordered and it has a less than or equals operator, and that's just essentially an abstract extension methods in the ordering class. So you get that when you have an ordering, you get the infix operator. You don't
Hmm.
need to import that with a separate import.
That's cool.
And and that works because extension methods can be abstract, which I'm not sure they can be in Kotlin, and because they can be bunched together in a class, which are sort of this bunching together is something that Dart knew,
Hmm.
and so we sort of combined the best of both worlds. And I like to talk about it now because this was really actually very hard. I think we went through 3 or 4 designs with that. I knew we wanted extension methods in the end, but the first designs were always improvable, and so we're very happy with the final version we have for that.
They are pretty cool. And just a note to people that this kind of work is hard. And I wanted to send a personal note of thanks to you for this work because it's important work and it's very difficult. And we never see this. If we saw like 1%, if we had to do that, even 1% of the work that you're doing to like fix like the tiniest thing, I think we would all get a much more appreciation for the kind of work that you're doing and into the Scala language. You said something about tooling that tooling is going to also help with these sort of issues that used to bite in Scala 2.
Mhm.
How are you thinking about this? How are how are tools evolving in that sense?
So I think where we made advances was this particular mechanism of import suggestions.
Hmm.
It's not only for givens, but also extension methods and others. The other thing is really the engineering of the error messages, where I think Scala 2 was, for its time, state of the art, but the state of the art has advanced a lot over the
Hmm.
last 10 or 15 years. So we're not alone. Other languages have much better error messages now as well. But I think in Scala 3, a lot more space, like they are longer, they have hints, they explain stuff. And thought has gone into error messages than before, and that's also helps learnability, discoverability of a language. And we could improve further. So, for instance, it would be nice to have more tooltips or things like that to say if you have an error, you could maybe already give them a hint how to fix it or things like that, or maybe even suggest it then in an IDE to have the IDE fix it for you. So that's sort of would be a nice further improvement.
That would be amazing. And also in the age of LLMs, where you would have to
Yeah,
like I don't know, ask Cursor or
yeah,
the
yeah.
IDE to solve it for you.
Yeah, and again, it's a lot of detail. So one thing that was particularly enervating in Scala 2 for is that you say, let's say it's a type mismatch error, and it says found list of T, required list of T. I said, what are you
Yeah.
talking about? Right? And you do get these things. So they're maybe not all the time, but you do get them. And what we do now is that if that happens in the essentially the error message handling, we'll figure that out and we'll say, oh yeah, of course they're two different T's, otherwise you wouldn't have an error.
Yes.
And then it would say, well, if there are actually two things that both print T, but they're different, then it will explain to you, it will give little superscripts on both of
Hmm.
them. It will explain to you what they are and where they come from. So you're not in this puzzled state where you say, I have no idea what the compiler is just trying to tell me here.
Yeah, error messages are really, I mean, they save the day if they're designed correctly, and I'm really happy that this sort of work is being added into Scala. And also into tooling, because in the developer experience, you're dealing with errors literally all the time. So as you're writing code, you don't end up with correct code from the outset. So you have to be guided by the error messages, and you're making progress as a programmer when the error message changes. So when
Okay.
you get into an error, then you fix something and you get a different error, that's progress. You know.
Yeah.
So yeah, this is super important. And speaking of tooling, I was wondering if or how do you deal with the pressure from the community or the industry to balance language changes or the evolution of the language itself versus this sort of developer experience kind of problems like tooling or error messages or compiler speed or that sort of thing. How do you balance the two?
Um, that's I don't think there's a clear partition between the two. Mostly we try to do both, but with the resources that we have. But it's sort of a lot of it is opportunistic. So it's not really like, let's say, in improving error messages. We don't really have a person who is tasked with doing that. It's sort of if somebody sees a problem and they see an error and said, "Oh, this could be formulated better," then it would be great if this person has time to actually work on that or tell somebody else whether they
Mm.
could work on that. It's a bit of a, but it's true that I mean it would be nice to have more resources to do that. Generally, the tooling things are, well, if you talk about smallish language changes, in which we didn't really do many anything different than smallish language changes, the effort that goes in tooling is at least an order of magnitude higher. So these are trivial compared to like even fixing one type inference bug.
Yeah. I mean, yes, because it has so many moving parts, and if you break something in the type inference, then the
Exactly.
whole world
Yeah.
can break, really.
Typically, a new feature is greenfield, so you don't conflict with anything. Of course, you have to make sure the syntax is unambiguous and things like that, but these are sort of known technologies, techniques to do that. This is not very hard.
And how about the desire from the community to implement or remove features in the Scala language itself, like the requests of the language itself? How do you deal with them? Is there a process, or how does this work?
So there's the SIP process, the Scala improvement process,
Mm-hmm.
and that. So we have there's a very detailed document that writes up how that works. So anybody can make a proposal. What you do if you have a proposal is you first go on the contributor Discord and you make that proposal there. You get a community discussion going on the proposal. If the community discussion is generally positive, then you're encouraged to submit that as a pull request to the SIP website, where once there's a pull request, it will be assigned a number, and the committee will essentially give it a first review. And then the committee can essentially say, well, we accept that, or we want refinements, or we don't think this is a good fit for Scala. That's possible outcomes. If
Mm-hmm.
it gets accepted, then it's not in yet. That's the implementation phase. Then essentially the community or people or is invited, or sometimes we take it on ourselves to do it, to actually have an experimental implementation. So
Mm-hmm.
then it's typically under an experimental language import that you can turn on to get the feature. And then there's a second vote after some experimentation and experience to say, have any problems come up with this feature? If not, and it looks like we still want to have it, then and the second vote is also positive, then this makes it into the language. Now we actually have even another stage that we optionally will have for many of the new features. That's a so-called preview stage, which says that the thing is in the language, but for one release or maybe two releases, you have to still enable a preview flag to get it. But preview is sort of much less drastic than experimental. Experimental is sort of really behind a lot of security fences that you say, if you have something which is experimental and you put that in a library, then all your clients must be experimental as well. So experimental is viral in order to prevent the virus escaping from the thing.
That's such a good idea.
Yeah.
Because, I mean, this kind of prevents the being bitten kind of phenomenon
Exactly.
that we used to see, right?
We learned from that compared to the Scala 2 macros, which was exactly this case. So we were not ready to release Scala 2 macros.
And everybody made libraries with Scala macros,
exactly,
and they were magical, obviously.
Exactly, yeah. But we said, well, at the time, we said, well, it's fine. We just make them experimental. That will signal the community that we're not ready yet to make these a standard feature. But of course, then nobody cared. They just turned on experimental and in their library. But then, of course, the end clients didn't have to do anything. They could just use it. So we learned from that to say, and maybe we're too strict now. We're really very, very strict with these experimental things. Maybe we should loosen up a little. I don't know.
I mean, it's probably a lesson that will evolve in time because the Scala 3 macros are also incredibly powerful, but they're also very sane. So I think people will still continue to build really powerful libraries and a very similar magic to what used to exist in Scala 2, but with also the nice fencing and security and good practices being built in. So I think this is an evolution.
Right. Yeah. You learn. The main issue with Scala 2 macros was that there were two issues, but one issue was that they really expose the compiler data structures wholesale. So they all were basically, you just got at them. The way the compiler was treating things, that's the view you had in the macros. And that means that once we did a new compiler for Scala 3, these macros had to die because they were tied to the old compiler. So essentially you can't swap your compiler without swapping the macro system. And of course, that's not a good state of affairs. You need to abstract. You need to say, well, essentially, how can we represent metaprogramming without reference to a compiler with all its gnarly flags and options and things like that?
How do you think the ecosystem is evolving towards Scala 3, given that so many powerful libraries were based on macros? Obviously, those macros had to be rewritten. How do you feel the evolution has gone in that direction?
Well, I have the impression that they have basically the large majority. I don't know of any important cases of libraries using macros that have not migrated. There is probably a long tail, so that we have to live with that. But all the big ones have migrated, and that is the one bit where migration from 2 to 3 is really difficult because you have to rewrite this code and sometimes even change your whole approach because maybe the old approach that was based on untyped trees or something like that wouldn't work anymore. So that was a lot of work. We knew we had to do it because, well, if you want a new compiler, you can't have the old macro system. And I'm glad that that's mostly behind us now. So from now on, it should be much simpler.
Yep. What do you think at this point? So Scala has evolved throughout the years. We're upon the 21st birthday of Scala this year. What do you think Scala's strengths are right now as it currently stands? And the reason I'm asking is because Scala used to be, at least when it was propelled into the mainstream, it was this very interesting and fun language that blended functional programming and object-oriented programming in a very expressive package. And so it garnered a lot of interest with a lot of very enthusiastic developers like, hey, this is a fun language. This is super powerful. We can write distributed systems. Oh my God, we wrote Twitter. We can now process billions of tweets and whatever with a pretty vanilla version of Scala. Obviously, they made their libraries and features and all that, but pretty basic usage of Scala. What do you think Scala's current strengths are at this point?
So one So I think so. First, Scala is a combination of object-oriented and functional. Uh, the industry has moved a lot into that space. So essentially, a lot of the previously object-oriented languages like Java became more functional over time. That means they adopted more features that you typically find in functional languages. They didn't adopt so much the philosophy to have as little mutation as possible, but the features are there. So lambdas, streams, pattern matching, records, all
Mm-hmm.
these things that got added to Java. Um, the other thing where Scala shines is this combination of safety and convenience, and I would add simplicity as a third one, even though people are scared. But I think that being scared of Scala is mostly that it's so expressive because it really gives you no restrictions that don't make sense. It's not an agglomeration of features. It's more really an orthogonal fusion of
Mm-hmm.
functional and object-oriented. So I think overall, conceptually, the language is very simple uh, and at the same time very powerful. So that the other languages don't have so much because they are more agglomerations of features. You could say you bolt on some functional stuff to essentially an imperative object-oriented core. But I think Scala always shines and continues to shine in this combination of safety and convenience that you say it's a low ceremony, simple thing. Things generally work like they advertise to do. So essentially, if you write a thing, then it does what you think it does, and at the same time, so in that sense, it's quite close to, let's say, Python, to mention another language, but it has a really solid, powerful expressive type system to sort of save you, have your back if you want to scale things up. So that was always the advantage of Scala, and I think it continues in that direction to be a pioneer. So we try to make it both simpler and more convenient and safer. So that's essentially the idea.
Yeah, this is an interesting combination of safety and convenience because the way that Scala was originally advertised was this scalable language in the sense that you could start like a prototype in just a few lines of
Exactly.
code and then you can still stay within the same language and obviously get exposed to the entire JVM ecosystem, but literally stay in the same language and build a product as big as you want while
Yeah.
maintaining.
Yeah. And the original adopters of Scala, a lot of them came from dynamic languages like PHP or Ruby in the case of Twitter. And that was sort of the same thing. So they found the dynamic languages very convenient, no ceremony and boilerplate of static type systems at the time, but they wanted the safety. So Scala gave them both, I think, and it ran on a solid platform, the JVM. That's also important.
And what would what would you say to people that are scared of the apparent complexity of Scala just by virtue of the fact that Scala gives you so much power that it's overwhelming, really? Because if you look at, let's just say, look at the features of Scala, you have higher kind of types, you have various contextual abstractions, and somebody gets scared of the kind of power that they use that they can use. That's on the one hand. On the other hand, in the realm of safety, you can design libraries that are so restrictive that it's overwhelming the amount of complexity that you have to go through just to make things work. So,
Yeah.
for example, if you look at effect systems, they can get really, really complex, like really powerful. And if you look at a library like HTTP4S, if you want to spin up an HTTP server, you kind of have to sit for 30 minutes just to make the compiler work. And it's not the fault of the compiler, it's just how the library is designed
Yeah.
so that it doesn't compile until you have everything set up. Whereas in
Yeah.
Python, you write like 2 lines of code, like import serve.serve at localhost 8080, right?
Right.
And
Exactly.
so by this contrast, you could argue that there is an apparent complexity to Scala that could
Mhm.
scare people off. How could we make sure or encourage people to try it out and see rather the convenience or the ease of use of Scala in the style of Python, even though you can go the other way and
Right.
have the
Yeah.
the, the apparent complexity?
Well, I mean, it's true. So you can go away, you can go the other way also in lots of other languages. So for instance, if you look at a typical enterprise Java code base, it's probably also quite
Yeah.
scary and complex and
Mm-hmm.
unwieldy and things like that. The thing is that usually you say, well, Java is, you don't say Java is complex, you say Java ecosystem is complex,
Mm-hmm.
because a lot of this stuff is actually not Java, it's XML and other
I
files
see.
and whatever. And I think in Scala, the problem is it's all sort of, it all has, all the complexity you see is in a file with a .scala extension, so it must be Scala.
Mm-hmm.
Yeah. There's very little I can do about it. I can only appeal to the community to sort of use the principle of least power and keep things as simple as appropriate. And I think that we are uh, generally not doing so well in that thing in the community. I mean, there are things that, for instance, you mentioned like web servers and things like that. I mean, you could have used Cask. Cask is basically they're directly inspired by Python Flask, and I bet you it would be much simpler to get that running. The so the one thing where I believe we're seeing a change is that a lot of the justification of this complexity came essentially from two sources. One was reactive programming because
Mm-hmm.
we didn't have virtual threads or coroutines on the JVM. You had to invent something. So Akka invented actors, and Cat's Effect invented essentially the effect systems, and Zio is another example of that. Um, and underneath them, in both Cat's Effect and Zio, are essentially very sophisticated, heavy-duty schedulers that essentially let you run massively concurrent applications that can process millions of events and things like that, which are sort of masterpieces of technology, I'm sure. But
Mm-hmm.
they are sort of for this specific use case where you need the scalability. If you're Netflix or Disney or something like that, you need that stuff. Not everybody does.
What do you
Um,
think would be needed in for like product development in that sense?
you
Like
can.
just like easy libraries to use, or what would you? Well,
I compiler is I basically only work on compilers.
mm-hmm.
don't have time for other things. And compilers are very specific things because compilers don't like any sort of dependencies
Yeah, not
because it's
no, not adding things into the compiler. I was
yeah, yeah. If I
more.
look what other people are doing, then I think something like how you stack is probably a simple way to get started.
Mm-hmm.
And uh, I talked with Hao Yi, and he said he's actually deployed that widely at Databricks, and there are 10,000 servers running this thing, and it's very scalable even with normal processes, and
This is
it should
amazing.
be better once you have Loom and coroutines. So I think that's the one sea change that you say now that essentially fine-grained concurrency is built into the JVMs with Loom, and we also have it in native with coroutines, and even ways to do it in WebAssembly in JavaScript, or they might come soon. So once we have that, we don't really need to have our own library-based super low-level schedulers and things like that.
Mm-hmm.
They might still have the edge. I don't know. I mean, they're good pieces of technology, but there's definitely competition. They're not the only game in town here. So now you can just use what the platform gives you. And I think the other thing is that there was and still is, I think, a bit of a glorification of pure functional programming and and super refined types. I'm not against that at all. I mean, I'm in WG 2.8, which is the working group on functional programming, and I'm
Mm.
good friends with Simon Peyton Jones and Phil Wadler and all the people. So I know what it is, and but I also know that it can be exaggerated. So there are diminishing returns for everything, and that includes full purity and essentially uh, expressiveness with typing. So you have a choice in Scala. You can be as fine-grained and coarse-grained as you like, and as usual, the optimum is somewhere in the middle and not on one of the extremes. Is my opinion here. So I think that's sort of if the community can sort of follow a bit more that advice, then I'm sure we would have simpler software in the future. And I think I'm seeing a path to there.
So I'm reading this as um, just write simple Scala because Scala is powerful enough and will give you pretty much all you need. If you want to go like super complex, you can go there,
Right.
but
Yeah.
it will get you very
You don't
far
need
just with.
exactly. Yeah. Yeah. Yeah.
Okay.
Yeah.
Uh, I was wondering if you. I mean, this was a question that I had in mind while you were explaining this blend and the trade off between uh, simplicity and convenience. Not the trade off, but the blend. Um,
Hmm.
and I was wondering if you have if you if we were in not in 2025, but we were in 2012 or 2013, and we would go to Java conferences again and start talking about Scala, but the way it is now. What do you think would be an underrated or uh, really valuable piece of Scala that would be very appealing to mainstream programmers?
You mean in 2012, 13, or now?
Now, so with the current
Ah,
state of Scala,
okay.
how would you appeal to the mainstream code?
Yeah. Yeah. Um, that's a good question. The it's it's difficult. So the thing is, you can say, well, we have lots of a very good blend of features that work well together, but it's hard to sell that, right? You say, well,
Yeah.
every language has sort of similar features nowadays, and
Hmm.
everybody says, well, yes, but I can do this in my favorite language in a slightly different way, but I don't see the problem or things like that. So you can say, well, it's really put together well. It's simple to get into. It's very safe. It's quite powerful in terms of runtime because of JVM. Um, the the other thing is if you want an edge like this functional object-oriented was when Scala came out, that
Hmm.
Scala was quite unique in that thing. Then what we are betting on is that the next kind of edge is systematic support for capabilities.
Hmm.
That's
I wanted
still
to
in
ask
the
about that. Hmm.
state, but that's sort of what I'm betting is that, I mean, Rust is making quite a splash, deservedly so. I think it's quite a big step ahead, but simple it is not. So I think there will be quite a lot of people very soon who are burned by Rust and say, well, no, this is super complex because the way it typically works, and we've experienced that firsthand in Scala, is the first generation that gets into a language is excited, is very excites others. They're the trailblazers, and they're typically technically quite good because otherwise they wouldn't be looking for new
Hmm.
technologies. And then the second generation comes when the first has long left the project and they see all this code, which means nothing to them, which just looks super complex. And they then go away and badmouth the thing and say, well, this is terrible, terrible code base and things like that. And I believe every technology is sort of software technology has sort of this life cycle. You can't avoid
Hmm.
that. And I think Rust is sort of at the beginning of that life cycle. It will come that people will find impenetrable code bases that are very, very hard to change. Why am I saying that is because I think that with capabilities, we can have something which has the functionality of what Rust gives you today in a much, much simpler package. So that's sort of the bet. And I can't really substantiate that yet much because we're still working on it.
Hmm.
I'm quite excited what we have and what we're doing next. So it's looking really interesting, but it's work in progress.
So, what is for the people who are listening or watching here on YouTube or other platforms? What is capability checking and how does it work?
Okay, so basically a capability is just a value, an unforgeable value that gives you a permission to do certain things. So capability systems have been with us for very long. They are essentially a proven mechanism in the security field, probably the longest standing, most solid mechanism there. The operating systems built around capabilities. There's even experimental hardware that supports it. So they are a way to make large systems safe because a capability lets you interface with untrusted code without violating, without fear that this code might call you back and violate some of your invariants. So basically, capabilities let you mix trusted code that you've written yourself, you trust your code, hopefully, with other people's code or maybe code that's untrusted, where you don't know what it is, because every piece of code, every component can only do what it is permitted to do with a capability. That's basically the idea. So if somebody calls you back with, like, let's say, a critical internal API and it's untrusted code, you don't know what they do, then you can protect yourself by saying, well, if you want to perform this operation, then you have to present the capability to do so. And if I haven't given it to you beforehand, then you won't have it because capabilities are unforgeable values. You can't just forge it. So that's the idea. And it's very, very old. The first capability system is from 1966, so it's almost 50 years old. But it's been an important technology. Now you could say, well, why hasn't it made it into mainstream? There have been a couple of attempts like Joey by Mark Miller for JavaScript and things like that. But why hasn't it made it mainstream? And I think the answer is, well, capabilities are values that you have to pass as to code with essentially to the methods that you want to invoke. So
Hmm.
you have to pass them around quite a lot. And that's just tedious. I mean, you might end up with, I don't know, dozens of capabilities that you have to handle and you have to pass them around. Imagine all these horrible parameter lists for these things. So that's why it hasn't caught on that a pure capability system is super simple. You just pass these things around as parameters, basically, and there's little else you can do with it. You can't store them in global values, so things like that.
It's a plain old
And
dependency injection all over again, right? I mean,
yeah, in a sense, yes. In a sense, it's exactly the
it's
same
why
thing.
dependency injection had these millions kinds of frameworks for doing the same thing because all the
Because it's too
dependencies that you,
hard to pass
yeah.
parameters. Exactly. Yeah, yeah. And Scala has the answer with implicit parameters that is a very solid way to use that and a way that we know really works. So if you use it in this way, then you won't see any of the tedium of passing around these capabilities. And the way we do it, that you can even avoid them having them to pass them at all at runtime. So you could say, well, maybe you don't have to write them, but it's still a drag on a system to have to pass all these parameters. It depends how you set up your capabilities, but there exists a thing of what we call erased capabilities, which you need only at compile time, so that the type checker says, well, you really have the permission to do these things. You don't need to have a proof at runtime to present that. So that's also possible. Okay, so that's essentially the capability-based systems, and the tricky bit, what's new, what we need to do is, so these capabilities typically you have to make sure they don't escape. So you pass a capability to something. So what you want to avoid is that other party stashing away your capability, maybe in a global variable or some object field or something like that, or maybe hiding it in the function result so that you return an object or a lambda that still can has access to this capability because then you can't bound the capability's lifetime. So you want to say, well, I give you capability to change this piece of store. But when you return to me, that capability is canceled. You won't be able to do that anymore. So you need a type system that tracks that, or a runtime system, but in our case, it's a type system that tracks essentially where capabilities can be propagated. So you can prevent them from maybe being stored in variables or being returned in hidden in results or things like that. So that's the first thing. And then the second thing is that you also want to have another restriction which says with capabilities, you want to have a notion of an exclusive capability. So for instance, I have a database and I want to write the database and I can't have a concurrent write with somebody else. I want the capability exclusively. On the other hand, if I just want to read it, maybe that is a shared capability that I can share with others. So you want to distinguish the two things. And once you are there, then you are essentially, you have a capability-based conceptualization of what Rust would typically do with a borrow checker. So Rust, the borrow checker doesn't work with capabilities, but it's essentially the same power. And the hope and I believe the expectation by now is that it will be a lot simpler than a borrow checker. It will be a lot less notation and a lot simpler to write correct code with that notion.
And how's the capability tracking uh, going right now? How's the progress?
So we are about to roll this out that it can be more widely used. So in one of the next versions, hopefully very soon, we'll have a standard library that is annotated with capabilities. Because the point is, right now you can use it. So it's a language import. It's called language import language.experimental capture checking. But the issue is, as long as the standard library isn't annotated, you can only do little standalone projects where essentially you have your own data types that you annotate with your thing. So the next step would be to annotate the standard library in collections. That's done also, but we still have to make that widely available in a release that other people can use it. So we have been using this internally for a while already. And then the next thing is to uh, essentially add this to code to a library stack. So there again, we have made some progress. So we have this Gears project that by now is also capability checked. So that, for instance, lets you say if you have an async context, so that's a context where you can suspend. So you can't basically try to suspend in code that doesn't give you the right to suspend, and you can't sort of leak that capability either. And then the next step after that is these exclusive capabilities, which are sort of right now they're not merged yet, but they're soon to be merged. Maybe tomorrow or something like that. We'll have the
Oh,
first
really?
version.
Wow. Okay.
Yeah, but it's
And
still it's bleeding edge. Yeah.
so at this point, you're going to make it experimental, and then you're going to roll it out to a wider group, or how would this work? To
Then we roll it out. We hope that once it's out as experimental and we sort of have caught up with the docs and things like that and are actively promoting that other people will use it, give us feedback. And depending on how that goes, it might find its way in a future Scala. I hope it will, but I can't promise anything yet. I think we have to do a lot more experimentation with this, whether to find out whether it has legs or not.
just to make sure, this is going to be backwards compatible with the Scala 3 generation. And this is going to get into the
Yes,
Scala 3, yeah?
yes, it's going to be backwards compatible. So we are not. Uh, yeah, it's going to be possible to make it backwards compatible, and we will in the first versions. Yeah. So there are other things that where you might want to exploit a new library design because capabilities give you more power. So, for instance, in the Scala library, we have these immutable collections and mutable collections and the common collection supertype that can be both. Basically, the supertype says you can't mutate, but somebody else can mutate the collection. And that is, I think, a solid design. But with capabilities, you can actually get a much simpler design. You can have the same array, let's say, which is both mutable and immutable depending on what kind of capability you attach to it. So notationally, you would say if it's a mutable array, then you would write array of t hat with the up arrow. So that gives you the right to mutate this array. But you drop the hat, and then you can only read it. And if you
Hmm.
return a fresh array, then and you don't return it with a hat, then that's actually an immutable array. So that gives you this sort of transient capabilities where you can mutate the array and to initialize it, say, and then you say you're done, and then from then on it's an immutable array. Right now we can do this only by copying safely we can do this only by copying the mutable array into a fresh copy, but in the future we wouldn't have to do this. So these are sort of technical advantages, but to exploit them, you'd need to redesign your collections to some degree. So right now, we're not ready to do that because I think that would be too radical. So I think we will give you the technical advantages with the library design that also profits, of course, but maybe is not optimal yet. Yeah.
So, what is your hope of like long term for the capability checking? What do you want to get to give Scala an edge over languages that have over the years have borrowed features from Scala? What do you think would be the advantage or the not just the advantage, the competitive advantage for
Yeah.
capability checking?
So I think it's a logical next progression step for Scala, particularly because it came from this fusion of object-oriented and functional or object-oriented functional with a bit of imperative. So it lets you do imperative, but it says, well, imperative, it's not predominantly imperative, and it also lets you write functional code. So where we were, and it's statically typed, of course. So where we were lacking is precisely at this interface between imperative and functional. We were lacking the types, right? So you could do anything from a function. It could have arbitrary side effects, and it was still syntactically a function. And the pure functional libraries say basically they go the way to say, no, you shouldn't have that. So let's just forget about mutable variables and mutation in Scala. You shouldn't use that if you want to be pure functional. They are not good features, but I think that from the philosophy of Scala, the philosophy is a bit different. The philosophy says, well, you can use them and you should use them when they make sense. They can make certain things simpler and more efficient, but we want to control them with a type system. So you want to say when you use them, it should be apparent in the types that this function has a side effect that might, let's say, mutate a matrix or something like that.
So you
And
basically
if
want
it's
to specify in the type within the time system when it makes sense and when it doesn't make sense to, for example, mutate something or produce a side effect, like within the
exactly,
type
yeah.
system.
Yeah. So the problem with global mutable variables and fields of global objects and things like that is that you can have incredible power by just using them for a side effect, and you can also do incredible damage by doing that to your system because your system becomes very unpredictable if you do that. I mean, we all know that. So the language response to that is to say, well, if you do that, you should pay a price for that, and the price will be more complicated types. So you need to sort of declare that you do that, And in a sense, the further away this variable is, the more complex the type tends to be that talks about it, what this function can do. And that should be an incentive for you to minimize these things. So previously we sort of have appealed to good sense, common good sense. Don't do these a lot. Don't do it if you're not happy with it. And people have generally responded to this, but there's the other mindset which says no, we have to have guarantees in place. We can't just appeal to common good sense. In particular, maybe you work with a team where you don't know all the members, and you want to protect yourself against these things. And then I think a type checker that actually manages these things is a good answer, and it's very much in the if we can make it convenient enough, it's very much in the Scala philosophy to do that. Scala as a bridge between these different paradigms, and as a language that encourages you to essentially mix them in a beneficial way.
This is very interesting, and sounds like it's a very powerful uh, set of features that would encourage, and not only encourage, but rather enforce safety, or various versions of safety to the degree that you can define them. So this capabilities essentially give you the possibility to define what safety means to you and then enforce that. Like
Exactly.
define a policy and then enforce that policy.
Yeah.
How do you plan on keeping the convenience part of it? Because this feature sounds to me, and maybe I'm speaking on behalf of at least some of my audience, that this capability tracking would have at least the potential, if you don't know how to use it right, to bloat the types or make the program very rigid or very strict, in a similar sense to how a library like HTTP4S doesn't allow you to spin up an HTTP server until you provide everything and have all the bits and pieces in place. How are you thinking of maintaining or encouraging convenience and also give people the power to express their own policy and then enforce them in large code bases?
Well, that is definitely the goal, that we can get there. But to get there, essentially, it's just a succession of trade-offs and design decisions, and sometimes inventions. To say, often we don't find a good way until later, and then we say, oh no, yeah, now we found a way that is lightweight enough to actually do that. What we saw so far is surprisingly good. Initially, I was actually, I have to tell you, I was scared of this project. I thought, well, this is beyond what we can do in a type system. And initially, I was trying to do a static analysis. So basically, a separate phase, not in the types of the compiler, that would sort of verify certain things in these things. And then the problem with the static analysis was that at some point you have to tell the system what your expectations are, and the best way that we know to do that is with the types. So then we were back with the types. The static analysis can infer lots of things to you, but the problem is then presenting what it found and comparing it against your expectations. That's where static analysis are very hard to use typically. So we said, okay, yeah, but a type, isn't that going to be incredibly verbose? But then through a sequence of sort of steps, we arrived at something which is truly very lightweight. So I give you one example. Let's say I have a map on lists. So map can be, and I want to not restrict it. So the function I can pass to the list can be impure, can have side effects. And the way I write that is exactly as I write it before. Not a single letter I need in addition. So it just works out of the box, and it works out of the box because now for us the double arrow means it's a function that can have a side effect, but the result is strict. So we get back a list, and we essentially encapsulate all possible effects. We don't need to talk about them. Then if you say, instead of a list, I want an iterator, I have a map with an iterator of the function. So Now I have a problem because I say, well, if I return an iterator with a map of a function, the function could have a side effect. So the iterator can have a side effect as well, right?
Yeah.
When I call next, it
Yep.
calls the function, it has a side effect. So what I say there is that in terms of capabilities, I just need to say that the iterator hangs on to the function. I do that with a hat and curly brace open f, which is the function name, curly brace close. That's it.
Mm-hmm.
So there is some additional notation, that's true, but I would argue it's actually very useful notation because if you have something and you say, okay, so here's this thing, and it might have a side effect when you call these things through some parameter that you've given, then it's actually quite useful to know, hey, this thing will, I pass the function f to my iterator map function, but the iterator will actually hang on to f and call that. That's for you probably good info to know, so to understand what your program does. And generally, we found that the notations we needed were mostly actually of this kind, that they were very helpful. So it's an improvement. You know better what your system is going to do. So far it has worked out well, but we're not done yet, and there might still be bad examples. Yeah. But for
Okay.
instance, the other thing that we have, which is also brilliant, I find, is so for the equivalent to borrow checking the exclusive capabilities. Let's say you have a function and it wants to multiply matrices,
Mm-hmm.
so and let's say it's not returning a matrix, but you give it two matrix input matrices and an output matrix as three parameters. So the way we write that is that we say, well, it gets a matrix and a matrix. We just write matrix, whatever the type is. And then the third matrix that it writes is a matrix hat. So the hat that says, hey, I'm going to mutate this thing, or I'm going to need an exclusive capability to this thing. And then what the system would do is it would verify that the two input matrices are not the same as the output matrix, because if they were, then of course your multiplication wouldn't work anymore. So you get this sort of alias checking and separation checking, and all you needed is a single hat on the output matrix. And there again, I would argue, well, that's actually very useful because for you it makes a big difference when you say you get, let's say, an array or a matrix. Are you going to mutate that thing or not? So that obviously makes a big difference. And it's good to have sort of an indication in the types. And what we have is sort of the shortest possible thing with this little hat at the end.
This is interesting. So with some a little token next to the type. So you're saying like a M hat or a matrix hat. The little hat that's the
Up
it's like
arrow.
up arrow, right?
Yep.
Is that signifies the ability to be mutated, or does it signify any sort of capability that you can track?
It signifies actually both, yeah. So the hat is basically the, you can say, capability polymorphic thing, or you could say the top in your capability hierarchy.
Mm-hmm.
So that could be any capability that is connected to that, yeah. But uh, so the hat gives you essentially the power that this could be anything, but for the matrix example, what it also gives you is to say, well, the things you could change with the hat are separate from anything else you can see. So I pass three parameters A, B, C. The C gets a hat, so the hat could potentially do anything, but it can't affect the A or the B.
Mm-hmm.
Because you see, so basically you say, well, I slice up my universe of things and I have various names that I know about. If something has a hat, it says, well, this is something that could change and it will be separate from anything else you can see. So it's sort of you won't hit a problem that you do a mutation by calling a method and suddenly something else that you see has changed. So that's an effect that can't happen.
That's very interesting. Okay, I'm very curious to see how this pans out. Have you used this in? So you mentioned Gears that
Mhm.
uses this. Can you explain for the listeners what Gears is and what its goal is?
Gears is a library for direct style futures and channels. So essentially a low-level concurrency library that that presents concurrency as essentially the active elements are futures, and they don't need a monadic bind to be called. You can just call, you say future dot await, and that will wait for the result of the future. And these futures can also communicate with channels. So channels are sort of the passive elements of communication. So it's futures and channels. They can also, of course, simply return results functionally if you want.
Okay.
That's what Gears is. It runs on Loom and the JVM and on the Scala native continuations.
Okay. I wanted to bring the conversation to the state of Scala in general, and I wanted to ask if you see something that would make Scala a really popular mainstream language, the way I believe it was meant to be. And I'm asking this because Scala has a lot of power, and because of that power, many very capable programmers came to the Scala ecosystem, and they invented these very potentially complicated technologies, and they're very powerful. They're very good, and they added a lot of safety into the products that use these tools. For example, like the effect systems and the actor models and stuff. But since other languages that are more mainstream, like Java, and to a degree Kotlin as well, borrowed the features that made Scala interesting when it was launched, like the blend of object-oriented and functional programming, that kind of left Scala to differentiate itself by its most powerful stuff, like the higher kinds and metaprogramming and contextual abstractions, and now the capability tracking. And so the differentiated audience now for Scala is essentially the pure functional programmers that are doing basically effect systems. So I'm curious how you see Scala progressing to a mainstream language with the kind of things that will be added or will be changed in the language. And I have a little qualifier to that, but I'm gonna leave you to this question for now.
That's a good question because I'm actually not sure. I don't think these things are plannable at all. So essentially, all you can do is develop some technology and tooling, hope that it will interest people, and then it depends very much on the other people what they do with what you put out there. And so it's difficult. So what we did with Scala 3 is essentially smooth all the edges, make it look more modern and simpler. Syntax, I think, is a lot simpler. It should appeal to people coming from Python, which is basically all the kids nowadays. This sort of thing. Whether that will help or not is a different question. I don't know. It depends on who next picks it up, how they use it, how they evangelize this, whether it becomes a movement or whether it becomes sort of gains steam or not. I'm not sure. Yeah.
Yeah, there's definitely an intuition there with gaining steam, because what I wanted to qualify the question with was the fact that at least in my mind, in my mental model, Scala is a kind of like a product in the programming languages marketplace, or not even just a product that would quote unquote sell to people, and as in convince people to use it and base their software and their careers on them, but also a platform in the sense that a programming language has the same property of a platform in terms of network effects, and a language has network effects in two ways. At least in my conception. One is the network effect of people joining the ecosystem and talking about it, which is what Scala did like 10 years ago when it garnered this interest of this blend between object-oriented and functional paradigms in a very nice and fun package that gathered a lot of interest and excitement, which caused people to build all these amazing libraries and tools and whatever. So there's one, there's the people with the network effects, and two, the network effect of the ecosystem of libraries and tools, which is something that that could explain the immense popularity of things like Python, JavaScript, and TypeScript, because new libraries are being built every day. There's this public repository of all the stuff that you can build with on the server side, on the front end, with various visualizations, various data processing tools, and everything else that you can build in these languages. So I'm wondering how you see Scala evolving or gaining steam, to use your words, in terms of these network effects.
Um, I think I completely agree with your theory that that's what it is. But as to the second part of the question, I don't know. I mean, I don't know what. Um, so when I see that, like the first wave was typically junior, well, maybe not junior, but small teams of engineers or maybe even grad students just doing something. So they were intrigued by the technology. Functional object-oriented was new at the time, and they built some stuff, and then that became large. So, for instance, Twitter, by the time they adopted Scala, they were altogether 25 people. So that was the size of the company. Fairly small company, but then they became big and powerful. Or Spark was the work of a handful of grad students at Berkeley. So that used that. So I guess what we're doing is wait for the next spark or the next people who pick it up. And then the question is why would they pick it up? And so there must be some unique advantage to it. And the advantage must be polished enough that they actually can use it in a product very quickly, not just conceptual, say. And that so I believe that as a first step, the capability story is a powerful story, and because it could be a game changer for security, and it could be a game changer for the sort of systems that have to be efficient but should be safe as well. So by having sort of an amount of mutation that you can have in your system without worrying about possible data races and things like that. So I think that's a possible game changer in some parts. In the long run, I'm also not sure. So we had in Scala Days 23, there was an interesting talk by Andre on the essentially the combination of programming languages and LLMs and AI, where he was arguing that life first was essentially slime, so mollusks and things like that. And higher life started when the skeleton was invented, when people invented bones and carapaces, hulls first, the bones came later. And he thinks with languages, it's sort of the same thing to say LLMs are sort of the origins of this thing, but you need clear structures in which you can build higher level things and have security guarantees. And I think for that thing, Scala is a good contender. Maybe it won't be Scala, but the language like it. That's also possible. Of course, I wish it would be. It's Scala, and I'm working towards that with what I can. But I think there is a thing to that you say if we have LLMs and code generation will become incredibly cheap because we will just give it to Copilot or Cursor or whatever, then you have still the price to ensure that this thing does what you want, that this is the right thing, that it doesn't have hidden bugs and things like that. And there, all the help you can get, you should take, because that will be the hard part that remains in the programming job. And a strong and expressive type system is one of the best tools we have now, and with capabilities, it will be even stronger. So my saying, well, my a potential future would be that these things will become important, in particular with AI.
This is, I'm also very, very curious, especially since Scala has historically pioneered many of the stuff that we now kind of take for granted. And we'll probably soon see a sort of capability tracking in other languages as well. Obviously, in 15 years, not
Well,
because.
I think there we have a moat, so to speak, because for this to work in practice, you need to have two features in the language, which for now Scala is quite unique in having them. One is implicit parameters, so not many languages, but maybe Kotlin is getting something like that after all, but not many languages have them yet. And the other is a lightweight dependent types, so types that can talk about program variables, parameters, and things like that. And there also Scala is quite unique that it has these sort of types. Not many languages do have that. So I think there will be some catching. Maybe other languages will catch up, but it will be some time until they do that.
Yeah. I mean, Java added pattern matching, what, 15 years after the.
Sure. Yeah.
Yeah.
But it's not that they couldn't have done it from the start. I mean, Java's precursor, well, not precursor, but my Java compiler's precursor was Pizza, which
Hmm.
was the language we did, and Pizza had pattern matching. But at the time we presented that to the Java people, they said, well, we don't. Uh, because Pizza had three things. It had lambdas, pattern matching, and generics. And they said, well, we don't need lambdas. We have inner classes. That's good enough at the time. That was like end of the 90s. Pattern matching is completely unobject oriented. We want none of that, but we want the generics. So can you maybe please write our compiler or take this and make it the next Java compiler? So that's how that happened. So generics came then in 2004 and lambdas in Java 8 in 2011 or something like that. And now finally pattern matching also made it into.
Yeah. I mean, yeah, there's a lot for that stuff to catch up to.
But pattern matching is in a sense it's less deep than dependent types. So dependent types would be it's more a surface feature, a very important one, and also full of sort of complexities with exhaustiveness checking and these sort of things. But it's more a surface feature in my categorization.
What is your hope for Scala over the next few years, and over the long run?
So first, I hope that we will move the community, more of the community, a lot more to Scala 3, and I think that's happening. So we
Hmm.
are encouraging that the first companies are migrating, and more companies are more young companies are just starting, and for them it's obvious to start with Scala 3.
Yep.
So I hope that will continue. The next hope is that as a community, we will put more emphasis on simplicity and the simplest possible solutions, and thereby also make the language more accessible to newcomers.
Hmm.
Yeah, and the third hope would be that at the end of this period, maybe we have a good foundation and a good language for capture checking for capabilities. So that's sort of the lab thing.
Yeah. I mean, yeah. There's a lot of potential there, and as a uh, as a teacher of Scala and as a Scala developer, I I hope to play my part in it, to make Scala more accessible and easy to get started with. Um, as I wanted to move to some more, let's say, quicker or rapid fire questions before we draw this conversation to a close. I want to be respectful of your time, and I really appreciate you making the time for this long conversation. The time just flew by for me. I wanted to ask you if you have a programming language that you admire, even if you're not using it, or if you draw some influences from while designing Scala?
Let's see. So right now I'm actually learning Lean, and I find it very, very intriguing. Lean is essentially an interactive theorem prover. So I find it quite tedious. It's surprisingly tedious to actually have to develop these proofs and things like that. But it's definitely intriguing what it can do. That you essentially you can state properties, any property, and prove it in the same program. So you have your program is a proof in a sense for the property it states itself. So this is quite cool. And Lean has a lot of, sort of in its notation and things like that. It has a lot of cool things, and maybe we can steal some of them for Scala in the future. I don't know.
In terms of, what would you steal from it?
So for instance, there's this thing called sections, where a section is sort of like an object, but it's not a separate object. So it's more like sort of a block of extension methods, but it's not linked to extension methods. In this section, you can declare essentially common parameters and types. So you can say, for instance, like f, your ubiquitous f is a monad or something like that.
Mm-hmm.
And that's a parameter in the whole section. So every time you mention this f in a parameter list of, let's say, an actual parameter or things like that, it means this definition. So basically,
Mm-hmm.
rather than repeating the same type parameters and formal definitions for every method, you just mention them, and it will pick them up from the section. I'm not sure what it can work quite nice in sort of avoiding the repetition and things like that. It feels a bit like avoiding the common prefix in the way we do bulk extension methods. But
Mm-hmm.
that was kind of intriguing to do that.
That's
The other
interesting.
thing,
Yes,
yeah,
please.
the other thing is it has a I'm not sure whether I should be scared by the of that or intrigued. It has a really cool system to change your notation. So you can have a very flexible thing that you define yourself, and that can is then notation you can use in your program. Because Lean is very math heavy, that's
Mm-hmm.
important because mathematicians are very creative in their notation. So the language supports that quite well. Um, yeah, so that was sort of some of the smaller things. Yeah.
This is very interesting. I'm gonna put this into the comment or the description of the video. Um, Martin, I wanted to thank you so much for taking the time to take part in this conversation. I really appreciate it. Before we wrap the conversation, is there anything that you would like to share with my audience or any?
No, I think we covered a large range of topics. Thanks for your questions.
All right. So for everybody who's listening, we're going to leave links in the so-called show notes. If you like this conversation, let me know. Give me feedback or comments in the next to the videos or wherever you see this or wherever you listen to your favorite stuff. And if you wanted to hear more from Martin, I'm going to leave a link to his profile, and you will find a link to the Scala language as well and to Martin's work. So, Martin, thank you so much for taking the time.
Thank you, Daniel. It was a pleasure.